Hello, my name's Gabe. For this problem, we're asked to find the mass of the surface lamina given by S of density rho. So the idea here that we want to use is that we know that the mass is given by this surface integral. And from this section, we know that we can find this surface integral by evaluating this double integral. So our goal here should first be to replace z with some g of xy. And the way that we're going to do that is by looking at this equation up here. So we know that we have 2x plus 3y plus 6z is equal to 12. We'll manipulate that equation in order to find a g of xy. So as I said, let's go ahead and let's write down that equation. So now we want to solve for z. So let's subtract 2x and 3y from both sides of the equation. And now we can divide everything by 6. So we have g of xy is equal to z is equal to 2 minus 1/3 x minus 1/2 y. So now that we've already found g of xy, just looking at this, we know that we're going to need the partial of g with respect to x, so the partial derivative of g with respect to x, and the partial derivative of g with respect to y. So let's go ahead and find those now as well. So the partial derivative of g with respect to x, looking at this equation, we're going to see is just negative 1/3. And looking at the partial derivative of g with respect to y is going to be negative 1/2. So here we have g, we have the partial derivative of g with respect to x, and the partial derivative of g with respect to y. So now we found everything that we need to find about g. Let's go ahead and let's now find our region R. So remember that this region R is going to be in the xy plane. So in order to find the region, we want to go back and look at this equation, so the same equation that we used for g, but here we want to let z equal 0. So we're thinking about this region as the trace of this plane right here in the xy plane. So I'm going to rewrite this, but I'm going to let z be 0. So we have 2x plus 3y plus 0. I'm not going to write anything. It's equal to 12. So now we can go ahead and we can solve this equation for y. So I'll subtract 2x from both sides. So we'll have 3y is equal to negative 2x plus 12. And the other thing that we can do is we can divide each side of this equation by 3. So we'll have y is equal to negative 2/3 times x plus 4. So if you want to think about, well, what are the bounds of a region going to be? You can imagine sketching this graph, and since our surface only lies in the first octant, well, this is only going to lie in the first quadrant in the Cartesian plane, so in the xy coordinate system. So what we'll have here is we'll have our y-intercept is 4. And our slope is negative 2/3 x. So what that's going to tell us is that we're going to have to come over 6 in order to hit the x-intercept. So in the xy plane, this is the region which we're integrating over. So here, we can either let, well, I guess here what we'd want to do is we'd want to let y vary from y equals 0 up to y equals this line, negative 2/3 x plus 4. And we're going to let x vary from x equals 0 to x equals 6. So now we can go ahead and we can substitute everything in. So we're going to have our mass is going to be equal to this double integral, this region R is going to be this region here, and let's integrate with respect to y first, and then we'll integrate with respect to x. So y, as we said, is going to vary from 0 to the line negative 2/3 x plus 4. And x is going to vary from 0 to 6. So now we have to fill in this information. Well, we know what rho is. We know rho is x squared plus y squared. So for this piece, we're only going to have x squared plus y squared. Since our density doesn't depend on z, we don't need to substitute this g of xy in anywhere. If this was an x squared plus y squared plus something involving a z, here we would substitute this g of xy in for z. All right, and now we have to multiply by the square root of 1 plus, well, the partial derivative of g with respect to x is negative 1/3, so it's going to be that quantity squared, which is 1/9. Plus the partial derivative of g with respect to y, that quantity squared, which is going to be 1/4. And as I said, we're integrating with respect to y first, and then with respect to x. So here, we can go ahead and we can simplify what's under this radical. And what we see this will simplify to is it'll simplify to 7/6. So this is equal to 7/6 times the integral from 0 to 6 of the integral from 0 to negative 2/3 x plus 4. The integrand here is just x squared plus y squared. And we're integrating with respect to y first, and then with respect to x. So now we just need to integrate x squared plus y squared with respect to y. So this is going to be 7/6 times the integral from 0 to 6. Here, if we're integrating x squared plus y squared with respect to y, this is going to be x squared times y plus, we can write this as 1/3 y cubed. And here, we're going to be evaluating from y equals 0 to y equals negative 2/3 x plus 4. And then we're going to finish this by integrating with respect to x. So, going ahead and doing this integral, this is going to be equal to 7/6 times the integral from 0 to 6. Here we're going to have x squared times negative 2/3 x plus 4 plus 1/3 times negative 2/3 x plus 4 quantity cubed. Dx. So here, we can multiply here, and if you would like, you can expand here, or you can leave this here and perform a u substitution to evaluate this integral. So if we imagine multiplying this through here, for the sake of space, I'm just going to write this down here, And we can write this as negative 2/3 x cubed plus 4x squared. So that when we come down to the next step and we actually integrate, we can just integrate this here. And for this piece here, we can say let u equal negative 2/3 x plus 4. Du in this case is going to be negative 2/3 dx. So now we just have to perform this integration. So this is going to be 7/6, and we're going to multiply everything by the 7/6. So integrating here, we'll have a negative 2/12 x to the 4th plus a 4/3 x cubed integrating here, we'll have a plus. Well, since we let what's inside these parentheses be u, we'll have a 1/12 and then we're going to be multiplying that by a negative 3/2 times what's in these parentheses to the 4th. So times negative 2/3 x plus 4 to the 4th. And we're evaluating this whole thing from 0 to 6. So luckily for us, when we substitute in 0, most of what's here is going to cancel. So let's go ahead and let's evaluate this. So this will be equal to 7/6. Here, this simplifies to a negative 1/6 times 6 to the 4th plus 4/3 times 6 cubed. Now here, we can imagine this 3 and this 12 give us a 1/4, and then we'll multiply 1/4 by 1/2. That'll give us 1/8. And since this 3/2 was negative, we'll be subtracting a 1/8 times negative 2/3 times 6 plus 4, this raised to the 4th. So this is what we get when we substitute in 6. Now when we substitute in 0, well, we don't have this term. We don't have this term. So the only thing that we have to concern ourselves with is this here. And we know that this is going to be a negative 1/8. So this minus sign will become a plus sign. So we'll be adding 1/8 times negative 2/3 times 0 plus 4 raised to the 4th. Now, you can go ahead and you can find this by hand, or you can use a calculator just to evaluate this. And using a calculator, what you'll find this is equal to is 364/3. So the mass of our surface lamina is given by 364/3. Thank you.